Hello, it's James from XRobots.co.uk. It's part 3 of my version 2 of BB-8, which I've got just here. So, confusingly, this video is actually being made well in the past. It's actually the 30th of October today, which is the date I published part 1. Part 2's already been made, and that's ready to be published next Friday in my time, but it's in the past for you as well. That would have been at least a week or two, possibly ago, depending on when part 3 comes out. So by the time you see this video, I'm actually working on part 4 or 5. So thanks for all the helpful advice, but it's actually too late. So what we've got here is a barrel, essentially, which is a section of a ½ metre diameter ball. And we've got an internal hub that turns round. Within that, there's a flywheel full of 2p pieces. And when that spins, it causes it to spin on the spot. So last time I sorted out some stability for driving, because it was very wobbly in part 1. And to do that, I'm using an inertial measurement unit from Adafruit. And I'm sending data from the controller over Bluetooth, then running the inertial measurement unit through a PID loop to control the tilt angle of the internal. Last time I worked on this dolly for the head, which has got a magnetic coupling to the inside, which allows the head to move in all directions, and it's got this separate hub in the middle on bearings, so the head can rotate without all of these casters changing direction. It's currently just stuck on with the plate in the bottom. Today I'm going to work on the arm that actually moves that plate around, and it moves it in all directions and turns it. And I'm hoping to use that for some form of side-to-side stabilization, but I need to work through that as I go. So let's have a look at some CAD. So this is what I've come up with so far for moving the head around, and it needs to move forwards and backwards in the direction of drive, and it needs to move sideways, and it needs to rotate. So what I've got, let's look at this red thing first. This pivots through the centre of the ball, and it has to pivot there so that, in fact, everything has to pivot there so it tracks the radius of the ball okay. This is going to have the magnetic coupling right on the top, so it has to track that surface as closely as possible. So the holes here, those go right in the centre of the ball on the internal hub. There is a sort of pivot thing, which is this thing sticking up, and that is going to be on an arm or some sort of linear actuator that I haven't designed yet that pulls it forwards and back. So the pivot point is actually right in the middle of the ball, and that moves backwards and forwards. The blue and green thing is made of 2 pieces, and that pivots through the hole right at the bottom of the red piece, and that is also at the same height. So it's effectively on the same plane as the centre of the ball. We've then got another shaft that runs right through the middle of the blue pieces. Let's just align them there. And that's going to be a piece of 6mm studding, which goes through bearings, and it's basically controlled by these gears, and the big gear is going to be the one that's fitted onto that shaft, and I've got a kind of thing here I can compress onto it by putting a hose clip round. And the small one is going to be fixed onto a motor that's mounted on the bottom blue block somehow with a motor mount I haven't made yet. That means that the piece of studding runs exactly through the middle of the ball. It's in line with the hole in the bottom of the red thing, and therefore everything pivots around that point one way or the other. Here are some of my parts that I've made. So this has been made in multiple pieces. So the dial piece, if we'll call it that, has been made in 2 bits of ABS, and I've put these back to back to take out any warpage so it's perfectly flat. That piece pivots on here, and this sort of holds it, so it's a bit like a strap, and that's printed separately to the back piece. I've also got side pieces that fit on here, which are still printing, and then I've got a piece of 6mm studding that goes this way, and that will rotate through these bearings. At the bottom of that is a gear, and I've got this hose clip which goes around here so I can tighten this and it squashes it, and that then grips properly on my piece of 6mm studding. So I've actually printed these gears, one on the motor, and they work pretty well. So I've still got a bolt here which I need to take out, or at least make shorter, and that actually goes into a nut. I don't know if you can just see, there's a captive nut in there it screws into. so that holds it secure against the flat of the shaft. So this will drive this round, and this is the head rotation. So I need to get those extra brackets printed and screw and solvent weld all of this together, then hopefully it should be clear what on earth I'm talking about. Here's the first aspect of that head rotating mechanism, which is the dial piece, which of course moves side to side. And I've mounted the motor there. I've just printed an additional block that's exactly the right height. I've got my bearings in there and in there, and eventually there'll be a nut to hold this shaft in exactly the right place, and I've got my hose clip on and a nut on the bottom. So this appears to turn quite well. I've actually got this connected straight to a LiPo, so let's just connect that. So that's alright, and then this shaft of course turns the head. Now it is going pretty fast, as you can see. There's nothing worse than a droid with a slow head, so obviously this is going to be speed controlled, so I'll be to slow that right down. And of course this shaft is turning all the way through bearings, which have just come out. Yeah, I really need those nuts to hold the bearings in. But this shaft is turning all the way through these bearings, and then it's turning the magnetic assembly that's turning the magnetic assembly on the outside, and that's turning another shaft through bearings which turns just the head shell. So hopefully that's enough torque. This is only a 30-to-1 geared motor. If it's not enough torque, I can go to 100-to-1. These are the discarded motors from my first ball balancing BB-8 that I then upgraded for higher torque ones. So I know I can get a motor in exactly the right size which will fit and rotate 3 times slower with 3 times as much torque. Here is the mostly assembled mechanism. So this of course moves this way, and it will eventually be pulled sideways by something depending on how much force it requires, probably a servo. Here's the pivot point for backwards and forwards, and that will get pulled against this pivot point, like so. And this pivot point goes right through, as I was saying, through the piece of studding, and so does this one. So this thing always pivots around the exact centre of the ball. So let's get that fitted inside, and we need to make a thing to stick the magnetic head coupling on as well, and then we'll see if that can move the head around and how much force is required. I've just attached this additional piece here with another hose clip that's attached to the top plate. So now as the motor turns, it turns this magnetic plate round. So hopefully I can now squeeze that in the top half of the droid. I've got my head lever mechanism fitted inside now. So I've got the magnetic coupling plate there on the inside, mounted on right on the top of that stick, and the one on the top, of course, mounted under the head here. So that allows quite a lot of travel backwards and forwards, and that seems to hold the dolly on quite well, and it also allows a little bit of travel sideways. At the moment the casters fall off the edge. Of course this will be a whole ball eventually, so that will give me much more travel, but that works quite well. Obviously if I push the inside it moves the dolly, so that works. Rotating also works, so I don't have to rotate this whole dolly. I can just rotate those magnetic plates, which means all these casters don't have to change direction. That seems to work pretty well. If I just connect that back to the battery, then you can see that that rotates. You can see the gears going round, and that will cause my head to rotate, and it can still move around in all directions. It goes pretty fast, and it still grips. So let's just... So I can drive along with the head rotating and everything should stay in place. So now it's time to put some actuators in to move the head backwards and forwards, and also side to side. So what I've done is printed this alternative piece, which is going to slot in place of this strap piece here that holds the dial in. So that will go in there. And this one has space for 2 servos, one at each end, so I'm using these. And these are 15 kilogram per centimetre torque servos with metal gears, and I'm going to have one at each end. And that is going to push across a linkage across the top between them that will in turn push that dial piece backwards and forwards. So I've got quite long servo horns on here. I don't think I need all of this leverage, but 15 kilograms per centimetre means at 1 centimetre length from the radius, it can, the stall torque at least is 15 kilograms, so they're fairly beefy servos, and I'm going to use 2 of them. So I need to get that implemented, and then we can hold this head at least in the middle, even if we don't move it straight away. Then I can see how it drives. The other actuator is going to act on that pivot point to move this backwards and forwards with some form of linear actuator coming up this way. Now that's something I will be putting on there so I can drive the head backwards and forwards. Although for driving, of course, I can fix it in one position and test it. Also, as the ball rotates, of course, friction brings the dolly in the direction of travel. So as the ball rotates forwards, the head will naturally move forwards with friction, as long as I've got some form of end stop in here to stop it going too far. So for the initial testing, I'm not actually going to put this actuator in. I'm just going to put the sideways one in, and then I can try banking by leaning the head, and I can work out the side-to-side stabilization. My servos are fitted, and I've put this link in which goes between them, and there's a bolt in the middle that moves that wiper piece. So now when I move this, you can just about see the magnetic grip thing moving around on top. I have to be careful not to drive off the edge. I really need the edges on the ball, but that appears to work quite well. I've put some foam end stops on here which allows this to come forward. That's the driving position to go forwards. Of course it'll pull this back slightly, and that's probably the head position I need for driving forwards. So the problem I've got is, of course, it wants to keep driving in that position, or in fact whichever way I put it, and that's because it's like pushing the ball along, and the inertial measurement unit that's stabilising it is trying to keep driving. So before I can try and use the head for side-to-side stabilisation, I really need to do something about that. And the plan is to put another inertial measurement unit on this piece, which measures the angle of the head, subtracts it from the other inertial measurement unit, and then it uses that value for stability, which means that as this moves forwards, it will compensate by moving the inside backwards. It should stay on the spot and not drive off, and it'll also remain perfectly balanced. I'm going to do that before I even think about putting the actuator in, so hopefully I can just leave it posed forward and drive forwards, and when I'm giving it a set point of 0, it's perfectly in the middle and stationary. I've now fitted another inertial measurement unit that's right in there, which is attached to this head stick, so it obviously moves with the angle of the head. I'm using an I2C multiplexer, which is another board from Adafruit, which is right here, which is combining the signal from both of the inertial measurement units. I'm not going to go into too much detail about that. I used this in Project Ultron to combine 6 of these inertial measurement units to make a motion capture suit. So if you want to know more about that and some of the issues I had initialising the sensors which I've worked around, then have a look at that. Have a look at part 2 of Project Ultron. So basically these IMUs are from Adafruit, they're BNO 055s, and they just give me the data, so they just give me the angle and they do all the maths for me. So all I'm literally doing is taking the data for the angle of the head stick and subtracting, taking that and taking the main angle, subtracting the head stick, divided by a factor of 3 to make up for the increased leverage, and then just sticking that data into the same PID loop that's running my main motor. And now everything's pretty stable. So now if I move the head forward, instead of it driving off, you'll notice the internal hub moves back a little bit, basically 3 times less the angle, and that stays stable instead of driving off. The whole thing is still stabilised, so if I push it, it still drives along. And if I put it back in the middle, you can see that centre hub moving back to the middle. If I put the head stick back, it moves the other way a little bit. So now this drives pretty well. I've got my side-to-side motion working. I've got stabilisation from wherever the head is. And let's give that a go. So here we go, we're going to do a complete test. I've got my side-to-side motion working and all the other things. So obviously as I move the head stick around, the inside compensates as I showed you. I do need to tune up that multiplication factor between the 2 IMUs as I build the head up, because obviously this will be heavier and have an influence pushing it forward. It does tend to creep forward sometimes, so I didn't get it quite right on a smooth floor, so I need to test that. But basically I can drive pretty well. Bear in mind the head is a bit wobbly, and that's because the head stick is actually wobbling around freely inside there. But also the dial part that moves sideways, there's quite a big gap in the slot it's in, so that moves independently. So I need to put a little bit of a guide in there, which I'll 3D print, just to keep that firm. Obviously there's no actuator at the moment, so it flops around in whichever way the ball is going to go. But it works pretty well. I'm pretty happy with it so far. Haven't retuned the PID loop either since last time, so I could look at that and retune some of those settings, but it works pretty well. With the head in the middle, I can still turn on the spot. That seems to work okay. And I've now got the ability obviously to move this head sideways on top. Hopefully you can see that pretty well if I don't drive off the edge. So if I don't hold the ball, then you know, I can actually introduce quite a bit of side-to-side motion here just by moving that. So I'm hoping to stabilise it sideways by doing the same thing, and this is very similar to the ball balancing robot I built, which is over there, where the head actually balanced on the ball. So if that works, you know, if I deaden this by hand, then it stays there. So this should be a much easier problem to solve, at least with the IMUs doing all the maths for me. So I should be able to easily stabilise side-to-side wobble by moving the head, which is the next thing to do. But apart from that, I'm pretty happy with how it works so far. It seems to drive okay. So it's really that and the linear actuator for the head we need to sort out. And at the moment I haven't got anything driving the head spinning motor, but it does spin round. Hopefully you can see this turning round as I turn the gears. So that's another thing that needs to happen as well, but it looks like it's pretty good so far. So let's talk about side-to-side stabilisation. Obviously this has some wobble in it as it goes. And it has no way of shifting mass to balance like it does to move forwards and backwards. So the plan is to move the head side to side to kill the wobble. Now what would seem logical would be that if it wobbles one way, to move the head the other way to compensate. And then as it moves back, move it the other way, and hopefully centre them all in the middle. The problem with that is, of course, that when you do this, it's actually pushing the ball further this way. And then when it wobbles back and it pushes back the other way, it's pushing it the other way. So what happens is you end up with this constant oscillation with it never settling. So in fact what I've done is moved the head in the same direction. So as it moves, the head moves this way and then slowly back, and that actually kills the wobble instead of it moving the other way and making the problem worse. So now as I move my head, or at least as I move the body, the head moves in that direction as well, which almost works to kill the wobble. Now I have a problem because I can't go as far as I want because it drives off the edge, unfortunately, but it does move in that direction and hopefully slowly back and settles, and that should kill that wobble. So if I now move this manually, what I really want is this sort of effect, and then a slow return to the centre. And the aim is to try and kill the wobble doing that. The problem I've really got is I haven't got all the mass on the head. My ball is probably a bit light in the bottom. And also I can't move the head as far as I want due to the sides here, which don't exist yet. Now I am prepared to put some more ballast in the ball, so it's going to be a bit of a balancing act as the head gets heavier. And I put the sides on, of course, which will increase the centre of gravity, being round with a middle at the middle of the ball. So I've got some lead shots here, which I got off eBay. This is for diving weights for scuba diving. There's 2 kilograms in here, despite its size. Lead is 11 times roughly heavier than water. So if it were water, it'd be 11 times the volume. There are some heavier metals, including platinum, plutonium and uranium, which are between 18 and 20 times denser than water, but those are rather harder to buy on eBay. I also found a suitable dome on eBay, so I'm aware there are some 3D printable files which have come out of the BB-8 builders group, but those are going to be about 2 kilograms to print, so that's quite heavy to put on the head. So I wanted to find a lighter weight solution that I can either use or vacuum form over to make the main dome. So I found this political globe, which is roughly 28 centimetres in diameter, or 11 inches, which is apparently the right size. And quite a nice globe of the world, actually. It's pretty lightweight, so I can use it as it is probably. And it's conveniently, if I throw this away, in 2 halves already. There was some glue in which I pulled off, and the bottom half has this nice brim that I can sit onto the sort of skirt on the bottom of BB-8's head. There's 2 halves here, so I could use either of them or both of them. So probably what I'll do again is vacuum form over it and then cut out sections and stick those back on like I did with the version 1 head. That should make a fairly lightweight head. I think that's probably a few hundred grams, if that. That's all for this part, but next time I'm going to be hopefully fixing this head on properly, looking at the head lever actuator that actually moves it backwards and forwards, and sorting out that extra wobble, and obviously getting those motors working, and also for the head rotation. So that should get us almost fully functional. I'm then going to be discussing putting the sides on, which, as I mentioned, I think in part 1, I'm going to hopefully have opening panels, because it looks very much like BB-8 is an astromech droid that rides in the back of an X-Wing, so it should have tools and things that poke out. And obviously with this design, never driving sideways, it gives me that opportunity. So I may also look at some other types of stabilization. We'll see how that head plan leaning goes. I'm hoping that I can kill the wobble, and if there is some wobble, the head just slowly compensates and it drives in a nice circle. Other solutions could of course be some mass that moves sideways inside, but basically that's what the head does anyway, right? So that's my thinking at the moment. So don't forget to check out the previous 2 parts if you haven't seen them, and my previous ball balancing BB-8 build. Don't forget to subscribe for more updates on this project and other projects, and check out the social media links in the description to this video.